Good afternoon, everyone. Before we begin, please confirm that you can hear me and see the slides clearly by just typing yes in the chat window. Also, we would like you to introduce yourself, your name, designation, company, and the country you are based in. I would like to thank you all for registering and taking time out on a Sunday to learn about effective use of wrench time data analysis to enhance maintenance department performance. My name is 𝐤𝐿𝐵𝐿𝐼 and I will be your introductory speaker for today. It's our pleasure to host this webinar for you. This is our 85th webinar in a series of technical webinars we are conducting. As a practice, we are conducting one webinar every month. Please follow us on LinkedIn, YouTube, and make sure to check our website for the latest updates. Today, we have an experienced panel of speakers. I am with my colleague, Mr. 𝐤𝐫𝐚𝐿𝐵, Managing Director, Principal Integrity and Safety Consultant, Madam Mubina Khatoon, Director, Engineering Services, and Mr. Anthony James William, who is General Manager, Global Sales. Moving forward, during this webinar, we encourage you to keep asking questions to clear any doubts. We would definitely like your engagement on this topic. You can type your queries in the question and answer window, and you will receive a reply in the question and answer window, or we will answer your question live. We will try to answer questions as much as possible during this session, and as we will have a detailed question and answer session at the end of the topic, please accept our apologies if your question is not addressed due to the high volume of questions we usually receive. So we have to be selective. Furthermore, we will also be issuing participation certificates to all those who have attended at least 80% of the webinar and have participated in the discussion through question and answer. Since this is a quite technical topic, we will only touch on key theoretical and practical aspects of effective use of wrench time data analysis to enhance maintenance department performance. In this limited 2 hours, we request you all to follow along with us and keep asking questions to help us make this session as engaging as possible. Before we begin, although most of us are in the comfort zone of our homes, we should be aware of emergency exits. We should keep a safe distance and generally take care of ourselves and those who are around us. Let us begin, and I will start with a brief introduction about 𝐸𝐿𝐵 and what we do. 𝐸𝐿𝐵 is a leading global consultancy firm that provides asset integrity management, HSE, engineering, environmental, and software solutions to the clients in the oil and gas, energy, power, and petrochemical industries around the world. We also have our in-house proprietary software, which is 𝐸𝐿𝐵. It is an industry-leading SAP-certified complete asset integrity solution, which is currently being used by oil and gas giants such as ADNOC, Dragon Oil, TANAP, and many more. Founded in 1982 in Malaysia, 𝐸𝐿𝐵 Group was acquired by Apple Spain in 2011. With above 42 years of experience, we have expanded our footprints to more than 86 countries worldwide by now, and we offer a full range of specialized consultancy services tailored to the energy industry needs. Here is a map showing the worldwide existence of 𝐸𝐿𝐵. By combining global coverage and local knowledge with our wide range of services, we can create tailored solutions to complex problems. Our range of interrelated services and integrated approach ensures that we can accommodate a wide range of projects. 𝐸𝐿𝐵 service coverage, we provide services to a broad range of industries, including but not limited to oil refineries, chemical plants, offshore platforms, structured wellheads, pipelines, and many more. Let us further dig into some of our services which 𝐸𝐿𝐵 provides. First of all, we have asset integrity management services, in which we cover risk-based inspection, RBI, pipeline integrity management system, structure integrity management system, inspection scheduling management system, asset life extension studies, condition assessment studies, condition-based monitoring, DCVG and CIP surveys, technical trainings, and others. Then we have health, safety, and environmental services, under which we cover HSEIA studies, process safety and risk studies, environmental studies, and occupational health risk assessment, OHRA. Under OHRA, then we have emergency management and planning, qualitative OHRA, quantitative OHRA, workplace exposure monitoring, industrial hygiene monitoring plan. Then we have engineering services, under which we covered conceptual design, feed design, detailed design and engineering consultancy services, operating manuals and procedures, design verifications and appraisals, fitness for services, as-built drafting service. As I've already discussed that we have an inbuilt software solution as well. So under software solutions, we have 𝐸𝐿𝐵, which is a complete asset integrity management system. Then we have 𝐸𝐿PHA, which is process hazard analysis. For petrol station risk assessment, we have 𝐬𝐵-PSRA. Then we have 𝐬𝐵-MTS, which is material tracking system. 𝐬𝐵-ERP, enterprise resource planning. 𝐬𝐵-CTR, which is cost, time, and resource management. 𝐬𝐵-FLOW, 𝐬𝐵-ORP, and 𝐬𝐵-feedback. We also provide audit and assessment services, under which we cover 𝐸𝐴S safety audits, technical audits, environmental audits, PSM audits, structural audits, electrical audits, and others. We also provide ISO consultancy and trainings, in which some of the names are ISO 9001, which is quality management system, ISO 14001, which is environmental management system, 𝐸𝐴S 18001, ISO 45001, ISO 50001, which is energy management system, and ISO 55001, which is asset management system. We also provide various trainings to our Velocity Training Institute, LLC, which is established in Abu Dhabi, from certified technical program to food safety trainings. Our trainings categories let you quickly select your chosen courses and ensure you to remain at the forefront of development throughout various industries. Some of the training programs we have already conducted are certified training, technical training, exam preparatory training, HSE training, training in oil and gas fields, ISO trainings, NIBOSH, IOSH, administrative and business related trainings, and food safety trainings. Coming towards our software solutions, first of all, we have Whale Plant Asset Integrity Management Software, which is a single resource software solution that allows oil and gas operators to identify critical assets. This slide shows the dashboard of our Whale Plant, which is built on modular framework, having multiple modules under one umbrella. Then we have 𝐬𝐵-ERP, which is enterprise resource planning software. It supports storage of assets data and associated management related activities and documents in one central location. The slide shows the dashboard of 𝐬𝐵-ERP, under which we can see there are multiple modules, including accounts, HRMS, payroll, CTR, sales and purchase, CRM, assets, MTS, project management, and help desk. Our third software is Whale CMMS, which is computerized maintenance management system. It is a powerful tool that keeps tracks of information about an organization's maintenance operations and facilitates to make informed decisions by planning. This slide shows the dashboard of computerized maintenance management system. Then we have 𝐻𝐵-PHA, which is process hazard analysis software. It consists of various modules, which allows different techniques to systematically identify and assess potential hazards in the industrial process. On the slide, you can see two different modules of Whale Hazard, which is Whale Hazard, the hazard and operability analysis, and then Whale SIL, which is safety integrity level. Some of our inspection equipment, let's go through them quickly. We use magnetic flux leakage, MFL, tank button inspection, then coating thickness measurement, ultrasonic pulse velocity, then long range UT guided wave, ultrasonic thickness measurement, positive material identification, PMI, tank weld inspection, wireless dynamometer tension, load cell. Then our equipments have ultraviolet imaging, edifying current testing, insulation resistance test, holiday detector, ultrasonic flaw detector, infrared thermography, RT projector, eddy current testing, PHUT, TOFT, advanced UT, ViewSonic 10, ultrasonic sound monitoring, video borescope, rebound hammer test. Velocity has successfully completed more than 1,200 projects with more than 400 clients who are satisfied with our services. So this slide shows some of our clients which we have already worked with. You can see the names of ADNOC, Dragon Oil, Saudi Aramco, BAPCO, CAFCO, KOC, Dolphin Energy, SNGPL, PPL, Petronas, BMC, GRN, etc. Here are some of our certifications, accreditations, and approvals and memberships. We have ISO 9001 quality management certificate, then ISO 14001, which is environmental management, ISO 45001, which is health and safety management, and we are also certified with SAP and 𝐸𝐴S. Some of our accreditations and approvals from different organizations that we have already received. Now I will hand it over to Mr. 𝐻𝐫𝐚𝐿, who will start with the topic of today.
Good day, everyone. Assalamu alaikum. You know that this webinar is being attended in various parts of the world, and somewhere it is early morning, and somewhere it is afternoon in the Far East, and it is 2:10 in Abu Dhabi. Today's topic is interesting one. It is a wrench time for plant maintenance, and wrench time is applicable in our all engineering disciplines. Even we are at studying, let's say, as a student, how much effectively we study, how much time we are looking for the notes, how much time we feel that now electricity is not there. When electricity will come, then I will study. Now I am waiting for food. Now I'm eating food. Now I'm waiting for tea. Now I'm drinking tea. So at what time, effectively, as a student, you are basically studying. That is a effective like a range time. Similarly, like in any engineering house, like we have, for example, generally what we see in general, we got 11-month working and 12th month is a leave time. On top of that, we get almost 8 medical leaves, and there are almost 10 to 15 national holidays. And then Ramadan month comes, where working hours are lesser, and then also efficiency of the people is also lesser. So if you see this, out of 12 months, almost 2.5 months, around 2 months are gone into the holidays. And then a person who is coming into the office, trying to do the job effectively. So what's happening? Coming in the morning, let's go to the tea. After taking the tea, first I should answer my personal emails, personal calls, and sometimes there's a call from home. And then somewhere we have to also chat about our surroundings, politics in our base countries from where we are coming, and who is supporting who. And then sometimes religious discussion, sometimes discussion on the movies and dramas, sometimes what is happening on social front. So if you see this, the effective time for the practical working would be very low, not only for maintenance, it can be applied on each part of our life. So it is a big challenge for all the leaders. So here, what I would be trying to discuss today, like how we can improve our work time and efficiency, not efficiency on the quality, and so like how much time I would be practically working on my laptop or effectively working on my engineering study, how much time as a student I would be spending with my book. Similarly, if I am a technician, how much time I am spending with my tools. So that is the purpose of the range time. Now, if you see that top quartile or top performance is not above 70-80%, it is a 50% and above. Like it means that the average effective time is around 50%, and where the second quartile is coming between 40 to 50. Third one is coming from 30 to 40, and fourth is less than 30%. So it is a challenge. And if we can improve the efficiency of our staff, our team, then it can easily be increased up to 60 to 80%. Not easily, it can be improved to, let's say, 50%, 60%, 70%. And in engineering houses, we have a challenge. Can we maintain over effective time up to 80% or up to 70%? Right? So this is a challenge for us. Right? So history, the time motion studies have been utilized for optimization and increase in productivity since the early days of the industrialization. Originally, 2 studies were done, time study and the motion study were utilized independently, but for later on, they combined to get better picture of the overall performance. The main idea behind the range time study is to capture time taken by an skilled craft worker to complete a certain task, provided all provisions and requisites are available, and then compare it with similar tasks performed by different personnels. The initial value is taken as a benchmark and used for all future comparisons. Objective. As I said in the beginning of my discussion, like objective is how effectively we can bring our staff for effective working and more work rather than ifs and buts, moving there, moving here. Those things we need to avoid. The range time studies are aimed at identifying the time lost in performing non-productive activities, whether personal or professional nature. Whatever work, as I said earlier, whether it is student related, whether it is engineering office related, whether it is inspection related, or whether it is a maintenance related. These things are applicable on all aspects of our life. So what we try to achieve as a part of range time study to identify non-productive time elements, to verify effective maintenance planning, to establish a baseline which can be compared with benchmarks as per best industrial practices, to identify the maintenance activities in need of optimization. So if we see this, like the benefit and limitations, here first thing is limitation wise, we are not like a quality and efficiency and the range time, three things go side by side. However, as one of the leader in the industrial sector, if I'm as a director of the company, sometimes people do come to me, sir, I am very efficient, but I spend less time. So other person is less he's less efficient and spending more time. I am more efficient, spending less time. So you see my work deliverable. So what I advise generally, so there are people who are more efficient, there are people who are less efficient, or there are some average efficient. So we need to have a productivity from all of them, so as we can have average or above average production of the company. So if a high performance or high efficient person will say, I will work only 2 hours, the low efficient worker should work 10 hours and average will work 8 hours. So that way company cannot work. So we have to work as per our best efficiency, and the range time or time being spent on the work has to be played by each individual as per the timesheet. So now what we have does not like the range time. It is only related to how much time we are spending on the work front. But efficiency point of view, quality of the work point of view, it does not identify those gaps, but those can be also seen as a part when we are doing the study as such for the organization. So now, like maintenance staff productivity level, industry average 35%, top quartile 52% as with annual tracking. The total man-hour charged to work orders as percentage of maintenance execution staff is 80%. Top quartile greater than 95%. Rework for industry average is less than 10%. It should be. And top quartile 3%. So mean time to repair, MTTR failure data, equipment specific, this is normal tracking information point of view. So now next thing, like during the course of execution of the range time study, more focus could be given to the following factors. For example, categories that are biggest distractor from the active repair time, need for development of a focused improvement plan, BOM improvement, reducing the time to LOTO or work permit system, improvement communication for the assignment, like improve operation and maintenance coordination, like focus on job plan improvements, like activity, material, tools, instructions, equipment condition, then mobile equipment assignments, need for standardized maintenance practices among different units. So these are also one of the important factors while assessing like range time. So now today, since we are mostly focused on the range time of the maintenance activities, so but this aspect, like other attendees who are attending this webinar may not be from the maintenance background. They could be from inspection, they could be from engineering, or they could be from any background of life. If we try to see like these activities, like a student I gave example, sometimes wasting time, like if I'm waiting for a tea, I can still study. If I'm drinking tea, I may also study along with drinking tea. Similarly, if any kind of condition, if I need to spend effective time on book, I should spend as a student. Next, the purpose of range time. The main reason for conducting range time studies to identify non-productive activities that are causing delay in maintenance activities, to identify the interdiscipline communication gaps, use data to drive improvement, not to assign blame. So caution, range time studies are not about finding personnel who are inefficient, making mistakes, or performing poorly. Though indirectly it comes, but not a direct product of range time study. The range time studies are about the quality of planning, scheduling process, and how effectively the organization executing both processes mean planning, scheduling, and execution of the job. Crew should be ensured that the study will only be used to drive positive improvements to avoid the backlash of the study. So how to improve range time? There are generally two factors contributing toward the maintenance cost, namely reduce the need to do maintenance like MTBF, improve the effectiveness of the resources needed to perform maintenance, people, tool, contractors, like all. Then this is where range time analysis come into play. A single change cannot effectively improve range time. It will be like other factors as well. For example, improve material coordination, BOM availability, for example. Number two, planning, like when this activity should be done. Then, for example, field supervision. Like if I give a practical example, I have seen practically the maintenance crew waiting hours to get the spare part so that they can go and do the maintenance activity. So why not spare parts or the BOM which is required to execute the maintenance activity, the BOM can be provided. Secondly, the operation department taking time of their own ease to issue the work permit, whether hot work permit or cold work permit. So most of the time is taken by them. Then planning wise, if any scaffolding required, any equipment access required, if the support department does not provide that access or the scaffolding, that will also take further time. So and so there are many factors which can affect, which are not under direct control of the maintenance crew. But same time, like when activity work is starting, crew go on break. There is a lunch time. Day would be ending, let's say 5 o'clock. The crew is off from the job at 4 o'clock. Oh, waiting for the bus. So 1 hour is waiting for the transportation in the morning and 1 hour in the evening and so and so. So all these factors basically gives you, if you have an idea, like how the improvement can be done in the range time. If I just give one example in 𝐸-VELOCity, we observed that all the inspection crews who were going in the field, previously, they were first coming to 𝐸-VELOCity office and then going to field. So first of all, the people would be reaching not 9 o'clock, maybe 9:30. Then they will be looking for their coveralls and other things. And leaving time, it goes to, let's say, 11, and then they leave the office. And reaching to site maybe 12, there's a lunch time. So till afternoon, they're unable to start the activities. So we looked at that part and then try to improve. Why not? Everything is given to the crew or inspection team in the evening, and then they go to site from home direct rather than coming to office. And it helps us to improve our productivity and range time. This could be one example for the contractors. So Kaizen is like how to improve or continuous improvement. This is basically Japanese word, and this range time also was driven from this concept. So small improvement effort usually done on small specific area by like a cross-discipline team can last a couple of hours for a few days each event, or it can be followed on the regular time. Like the concept is, if we try to monitor the activities which are being done by various staff members, then we can find the gaps, and those gaps can be filled as identified with the benchmarking. And then the efficiency, number one, the number two, the range time or the application of the work techniques, and the role of the support teams or the other corresponding departments like operation, HSC, logistics, and warehouse. Those could also be improved. So the aim is to improve zero losses through waste, identifying any correcting problems with flow, improve the effective use of assets, reduce manufacturing cost of the maintenance. So our approach now today, I am presenting one case study. Practically, we carried out this range time for one of the hydrocarbon facilities many years ago. So we have changed the data, and this study was done almost about 10 years ago. So I think the history has changed, so we can share some part of it. So as other industry player can learn from it, we have seen many companies are coming forward to look at the efficiency in terms of production and in terms of the effective use of the crews. So how we do, we are presenting by 𝐸-VELOCity way, and other companies can do by their way, but we are presenting how we have executed this kind of task in past. So first, data collection, then review of policies, strategies, and maintenance management system, resource verification, classification of the activities, resource coding, work sampling and work order selection, field observation and data capture, work sampling calculations, detailed data evaluation and analysis, reports and results, observations and improvements and recommendations. So same aspect is now presented some basically sequential way. So here the first step is same data collection, which is PMR, BOM, task list. Then initial review of the current strategies, assessment of the data within CMS, PMR associated BOMs, and resource planning verification. Then category definition, for example, instrumentation point of view, control, instrumentation and control, electrical, mechanical, and so on. Then resource coding, which is manpower, work sampling, work order selection, then collection of observation of the data, field observation, then work sample calculations, data evaluation and analysis, then overall results, analysis reports, and observations and recommendation. So the job is done in basically 11 steps. So how we try to do it, like let's say a team of 12, 6 engineers, 6 technicians is mobilized by Velocity, and it will have like 6 engineers, 6 technicians, like 2 electrical, 2 instrumentation and control, and 2 rotary side, and along with their technicians. So we are trying to follow 6 teams each, like 6 teams, 2 teams each in different areas, and we try to monitor how the various crews are doing their jobs by shadowing them and by monitoring their time log as per the application of the activities. Here, so data collection, as we do the like PMR, mean like what activities are planned for that particular month or particular week or particular day. Then by taking the PMRs and PM plans, then task lists and job plans, then resource lists, crew, crafts and identifications, associated BM where available, any additional documentation as applicable. Then initial review of the current strategy and assessment of data within CMS system hierarchy, functional location and units, then object sub-object relationship, associated drawings, identification marks, then equipment tag details, PM plans, job plans, task lists, preventive history if available to gain a better understanding of the job, then spare consumption and with reference to the work orders. So here, like collect document were reviewed basically for the following factors: the daily and weekly schedule overall, selection of work order CMPM, associated job plan, task list and the checklist, verification of available resources as per daily schedule, verify the job plan according to the job performed by crew. Here, then classification of the activities categories point of view, total time is measured by utilizing the following categories: wrench time, the time when a maintenance craft worker is applying physical effort or troubleshooting in the accomplishment of the assigned work. Productive time mean like the time directly related to the accomplishing assigned work, pre and post job brief, cleanup of the job sites and work travel. This is productive work. Then next, the non-productive time mean the time not directly related to accomplishing the assigned work. For example, training, breaks, lunch and idle. Area available for improvement to increase wrench time. For example, waiting time for material tools, waiting for permits, waiting for others, waiting between jobs, as I explained earlier in the beginning. So material like the crew is waiting for material from the warehouse, work permits from the operation and assigned by the HSE, then waiting for the, let's say, scaffolding, removal of insulation, or any support what you need from the other department. Then waiting time between jobs like inner coordination between electrical, instrumentation and mechanical. So that is also a factor. So classification of activities categories tailored for this particular project we are saying here, what we applied. For example, working, work travel, setup and take time, work assignment, wrap up. Then miscellaneous, for example, meeting, training, idles. Then waiting wise, waiting for material, waiting for tool, waiting for instructions, clearance, delay, work permits, multidisciplinary support, isolations, waiting for operator, weather delay also comes in. Now, resource coding like electrical supervisor, electrical technician, electrical helper, INC control supervisor, instrumentation and control technician, instrumentation and control helper. Then rotary equipment or static equipment, mechanical supervisor, mechanical technician, mechanical helper or others. So their employee number, designation. Then accordingly, observe, use list of crew employees to create a sequential observation strategy. For example, we try to do time of the day. We'll explain further next. Then category point of view, work order tag number, observation date, day of week, supervisor ID, then observation time and comments like traveling to the work site, waiting for permit, working, waiting for operator, waiting for operator and working. Similarly, time wise, like 7 to 8, it could be a 7 time, 8 to 9, time 8, period 8, 9 to 10, period 9, 10 to 11, period 10, period 11. Similarly, so we have categorized these 16 periods, and then accordingly, time is monitored in minutes, basically. Then collection of that data, collect data has been observed as a complete maintenance day and analyzed in a accumulated basis. Then sample collection mean an example assessment conducted on a maintenance crew, for example, 7:45 a.m. to 16:30 hours can be calculated as total time work one worker into 8.7 hours, right? And this is the 525 minutes for that particular 8.75 hours. There are two formal breaks, 15 minutes break, a paid break at mid morning and 30 minutes paid break, lunch break. So now if we see this, if we multiply total range time, let's assume 25 minutes divided by 85 minutes of total, then range time is calculated as 0.294 into 100, which is 29.4%. So in this way, by having traveling time, traveling to work site, waiting for permit, working, waiting for operator. So this way, all these minutes are summed up and ratio is calculated. So in this way, if you see a bigger picture, now this time calculated is in minutes and working, work travel. So we have basically observed various workers in their categories identified. Then accordingly, the time is noted and you can see the percentage in between. The permit delay is also 6.9% time. Isolation is 1%. Then idle time point of view, if you see 3%, then unaccountable is also 0.7%. So this way, various categories are identified. Secondly, if you see the calculation for discipline wise, the first is in the electrical, then control, and then mechanical. If we see this idle time in one area, it is about 3%, 2.9%, and 4.4% also on the mechanical side. Similarly, if we say permit delay, 8% in electrical, then 7% in controls, and there is also 7% in the mechanical side. So you can see where some improvement can be made. Also, if you see work assignment, 5,526 minutes, which is 12% in the electrical side. And similarly, 17% in the instrumentation and control. The work is not assigned to the technicians even. Then if you see the mechanical side, there is also 15%. So it means that the work could be assigned in timely manner by the planning department a day before or a week before. It can also improve the range time for the maintenance crew and technicians. If we see these calculations, previous one was if I go back, this was per discipline, electrical, then controls, mechanical. Now we have electrical, but in different process plants like hydro skimmer, hydro cracker, tank farm, jetty, utility, condensate, diesel or gas area. So here, how various areas we are having range time. If we see, I can, because since my time is limited, so I may not go all the categories, but if you see the working, for example, in hydro skimmer, it is 24.5%. In hydro cracker, it changed to 45%. Then tank farm, it became 42.7%. Whereas jetty, 20.3% only. Then utilities, 30%. Condensate area, 33.3%. Then diesel area, 44.8%. Then gas area, 32.8%. So if you see this, the highest one is still working time is 45%. So this is the challenge. So this is the comparison. And now the leadership can sit, make an analysis where we can improve. The waiting for operator, for example, waiting for tools, whether may be out of our control, the work assignment at least. For example, if you see hydro skimmer, work assignment is 35%. In hydro cracker, 15%. Tank farm is lesser, 4.8%. Jetty, 14%. So utilities, 12%, 8.4%, and 7.5% or 16.4%. Same as travel time, 4.9%, 9.7%, 23%, 13.8%. So there are significant time which can be optimized and the work productivity can be improved. So here, same aspect, control. Previous one was electrical. This is control. Here, if we see working point of view, only 20% hydroskimmer, 23% hydrocracker, 31.9% is the tank farm, 21.1% in jetty, utilities better, 43%, condensate 30, 34 and 30. If you see this, if I and C, practically first of all, discipline point of view, the electrical efficiency, the working point of view, range time is better than instrumentation, and then it also varies from one area to other area. So if this kind of comparison can open the eyes of leadership, and if some time is spent by the company or it is spent by some consultant to do the study of their crew, how they are behaving, how they are working, there could be different, we should be positive also about them. There could be areas or circumstances which could be beyond their control. But if you see big difference, first of all, job assignment, if you see here in both area I and C, 32%. In the hydroskimmer, 1/3 of the time is being spent, the crew is waiting for the time to be assigned, job to be assigned. Why so? Why we cannot plan earlier? If you see mechanical also, hydroskimmer 24%, then 28%, 45%, and highest is 45% in the mechanical side as well. And work assignment in the mechanical is relatively lower than the other discipline, but still they're taking significant time. Now, if we see this, next, a total calculated time and the percentage, the working is on the average is 37% for all the discipline, 37%, whereas the top quartile, it was should be more than 50%. So 13% gap is there. The work travel is 7.6%. And if you see other side, unaccountable is there sometime, but the main aspects, we can get some picture, sometime, right? Next, work sample calculation on discipline wise again, if we see, so here the percentage on working, the electrical is 38%, instrumentation and control is 31%, and mechanical is 39%. So one indication is coming, the instrumentation and control, their efficiency is lesser. But if you see that the most of the work activities or most of the assets in any facility are instrumentation and control, which are in normal percentage wise, the transmitters, the control valves, other items, they are more than 50% of the total assets. So, and their efficiency is the lowest, 31% versus 39% highest in the mechanical side. So, what we are trying to present in today's webinar based on actual study what we have done. See how much gap is there, and in increasing the efficiency or the range time of the technician on the work, and how much cost saving can be achieved, and how much work can be done more and more effectively. So there are gaps, and if this webinar carries some message to the operating companies and their maintenance team leaders, and if they can look around these aspects, so it is usually beneficial. Next, same as some comparison is there, utilities, desalination plant, seawater and sulfur area. If you see here, working point of view, here 42% is the utilities, 32% is in the desalination water, and there's a seawater is 41%, and it is 34% in the sulfur area for electrical. Similarly, for the control side, again, the working efficiency is lesser in terms of basically efficiency of the, I would say, range time on the working side. So again, I would like to qualify, because here we are trying to show only range time, how much rework, how much ineffective maintenance is being done. Those are the separate parts. But if a leadership would be willing to look into these aspects, then certainly there would be improvement in the productivity of the plant. Also, when we are looking at the productivity, at the same time efficiency and KPI of the effective maintenance or preventive maintenance, effective corrective maintenance, effective condition monitoring would also be assessed. So if I try to bring into the point, if a preventive work order is issued for a pump or for any other equipment, and if a month later the corrective work order is coming, either the PM was not done or PM was ineffective. Otherwise, why the corrective work order has to be issued after 1 month of the preventive maintenance? So other part also here, when we are doing these kind of studies, the concept of truth has to come. These studies can be done if PMs are being done as per actual plans, whether PM or CM, and data is being stored as per the true picture, and the keyboard warriors the SAP the planning engineers are not only issuing work order, they're closing themselves. That should not happen. If that is happening, then everything is in the darkness. The first thing is the truth and true use of the SAP or Maximo or Oracle or any CMS system you are using. So if there's a preventive maintenance, it should be preventive maintenance. If the corrective maintenance, it should be recorded as corrective maintenance. And whatever tasks are being done, those should be done in the true picture and data should be recorded accordingly. Now, next, like data evaluation and analysis, like what we made. So here, during the course of this project, calculated data has been thoroughly analyzed and detailed calculations were made, and analyzed data can be reviewed as overall range time, discipline-specific range time, plant-specific range time, as you have seen the example, then contract direct hire range time, total minutes captured per category, time of day-specific range time. Like one thing we should also be fair when we are working in the Middle East, in summertime, weather is very hot and humid, so it is a problem. But in winter time, efficiency or the range time could be a lot better as compared to summertime. And those factors we always take into account. So a clear baseline has been established that can now be used to drive improvement under the future studies. Here, we have performed detailed data analysis for all units captured under the project. Analysis has been performed using best industrial practice and with a minimum margin of error. Collected data was observed as a complete maintenance day and analyzed on the accumulated basis, basically. The time motion observations were made for scheduled and present workforce, temporary and non-basically working crew members who are excluded from the study to avoid any non-realistic data. Special care was taken to ensure that the margin of error shall be minimized and yet collect time frame should be presentable. Activities for less than 5 minutes have been rounded off, basically. And this is another way of basically showing the range time as such per category it is, right? If you see this isolation time, training, ship loading, so all categories, weather, and so on has been identified and overall percentage has been basically divided. So another way of the presenting the same, like the percentage of each category can be shown in this form of the graph as well. This is another type of the graph where various categories and their percentages are shown. And these graphs are basically generated from the Excel graphic representation. Now, overall result, if I try to go into, it is like more theory and there are like various slides are there, but whether it would be interest of any one of you or may not be, but it is like representing a result of this study. The best-in-class target value for oil and gas are generally between 45 to 55%, whereas this our company got 37. This target value is typically not achievable without a robust and mature planning practices and highly proactive maintenance improvement. But if you see 37 versus 45, so there's a difference of 8%. And this 8% means the cost point of view, if this company is spending, let's say, $200 million per year on the maintenance crew and those people, 8% is a big number and a big saving if it can be improved. Similarly, extensive use of predictive technologies for early identification is typically necessary to provide planner with enough of backlog of the plannable work to result in a good effective planning. For example, there was a lot of corrective maintenance or the shouts coming from the operation, and every night the technicians are being sent here and there by the planning people, then they cannot plan. Then they have to wait, they have to do things in a hurry scenario, what we say. So if you need to improve, then there should be more condition monitoring, more effective planning, so as the effective use of people and resources can be made. So during the course of this project, calculated range time is approximately 34%, 37% it has been improved. Before it was 34%, but after revision or discussion with the company, it reached to 37%, which is a good average, but coordination between different activities need to be improved in order to enter the top, basically, quartile of the companies. Following areas have been identified for performance improvement. For example, improve isolation and permit coordination, work permit coordination at the start of maintenance day. improve material coordination, increase field supervision and coordination between maintenance crew and the supervisors, decrease, optimize travel time, measure progress, coordination to help improve planning and scheduling. For example, like now, like we got various observations, so I can go through as a learning lesson for the other or operators or any other colleague who is listening this presentation. I will also be taking a few questions and at the end of this presentation, but I go through one by one. It has been observed that material management and movement takes sufficient part of the schedule, although maintenance supervisor try their best to minimize the effect by reassigning the crew for different tasks, but the solution is temporary and also consume more time in terms of work assignment. At the same time, material approval process seems to have an excessive need of approvals. So it's recommended if this job assignment and approval process can be optimized. This is one of the major observation. If you see that in the my previous presentation, sometime 33%, 35% time is being spent or being wasted in the assigned, like the technicians are sitting, they are not assigned any task. That is one of the area. Second, for example, it has been observed that the quality and the methodology of the maintenance work performed varies from area to area. Generally, crew reporting to the same supervisor has similar technical ability and quality of the performance. This can cause basically variation in the quality of the work performed, and the variation is not presently been accounted for when evaluating the maintenance activities performed. It has been observed that some supervisors fail to attend the planning maintenance meetings with the area planners and the schedulers. This makes it impossible for the planner scheduler to check the ground realities before issuing a proper work schedule. If this planning executor or the team leader of the maintenance activities should be attending these meetings with the planning and scheduling team. Similarly, like job plans, like task lists, checklists are outdated and sometimes impractical. It has been observed that for the same equipment and frequency, multiple job plans exist in Maximo or SAP with huge variation in terms of activities as well as resources. So if the job plan task list could be improved in an effective way, so it can help to optimize the job activities. Similarly, although company maintenance management system caters for most aspects of maintenance performance, but it has been observed that maintenance quality management system is not in place. Only assurance for the satisfactory maintenance is acceptance of the equipment by the end user. As per the best industrial practice, there should be firm quality management system in place. Then this could be done. It has been observed that the CM orders are raised for any malfunctioning equipment without a proper root cause analysis. So this could also improve the efficiency if some root cause analysis could be done, so as reoccurrence of the same failure could be avoided. Next, during the review of the company work management procedure, it has been observed that maintenance policies are in line with the best industrial practices, although there is only one backlog for both preventive and corrective maintenance orders. So it is recommended that separate backlog should be used for planned and corrective maintenance. So we can identify how much backlog is there for the preventive and how much backlog is there for the corrective. It should not be the case like the planned activities are being considered as a corrective activities. It does happen sometimes, like the PM is not done, but when equipment is out of order, at that time PM is done, but CM is not being recorded. It's a misguiding situation sometimes. So during site data collection, it has been observed that maintenance technicians are also supporting the ongoing project activities. This has been observed to go beyond the few hours a day. Due to that task assignment, the technicians are either unable to complete the scheduled tasks or have to work extended hours without any appropriate justification. Whatever the task is, it should be clearly assigned. And we should not be giving the double work to the same supervisor so as he is unable to complete either task. There's also some job segregation issue is there with the technicians. For example, the other part, like a work assignment and waiting for instruction, this has been one of the observations. It has been observed that the operational department raising priority work requests without registering in Maximo. And then shouts comes like, come here and do this and go there and do that. So if there could be a proper priority in Maximo, if the work orders are basically generated for the corrective work orders, and then assignment, if there is any priority comes back and forth, like we know that that problem will still persist. But if some sort of priority, some sort of registration of these like corrective work orders in Maximo or SAP, if that would be done, it will help to prioritize the work orders. This could be one of the issue where the maintenance crew is, especially in instrumentation and control crews, moving back and forth, and they are sometime under huge pressure. Then, for example, it has been observed that the oil movement crew and supervisor do not have sufficient access to the communication or transportation equipment. Sometimes maintenance crew has to go around by bicycles. So it means the transportation equipment, if they're not provided to maintenance crew, they would have a problem. It has to be improved. Next, it has been observed most of the critical drawings are outdated. This causes a delay in acquiring correct documentation to start work. In some cases, like if the drawings are not as built and the OEM latest data is not available for the maintenance crew, then it would be problem. So those should be improved. It has been observed that isolations, electrical isolation in particular, are initiated only after the start of the maintenance day. This delay all proceeding activities related to particular equipment. Then if something can be planned earlier, it can help to improve the efficiency of the technicians. It has been observed that the maintenance crew on most units finish their duty, let's say by 15:45, after which they wait for supervisor for next assignment, or some cases perform housekeeping. The record from sulfur area are quite alarming, where maintenance crew is under instruction to wrap up by 15 hours. We believe that this specified time is excessive just for housekeeping and can easily be used for scheduled maintenance activities. This is one of the observations. So it has been observed that some of the equipment in Unit 41 are past its service life, and maintenance staff is having difficulties in basically requisition of the spare parts. It has been observed that some of the new equipment does not have adequate number of reserve spares available in the warehouse. This causes a serious delay in maintenance activities. It should be improved. Then it has been observed that temporary workforce is presently not being scheduled and can be utilized as per work requirement in multiple areas. This is a contradiction of the best scheduling practices. It should be improved. It has been observed that in some cases, equipment schedule for PM was mechanically isolated in the morning strainer cleaning. The maintenance crew had to wait for equipment temporary temperature to normalize before it can start the work. It means planning part was missing. So it has been observed that in some work schedule, absent manpower has also been scheduled to work. Like the manpower is not available, the person is on leave, but the job has been assigned. This has been one of the observations. Similarly, it has been observed that general consumable items, for example, WD-40, not available. It has been observed that rare cases equipment schedule for PM is either wrongly identified by operation maintenance or sometime not found at all in the planned area. This could be a worst scenario, but it does happen in our observation, and we note it in few cases. It observed that the PM job plans estimated time are not optimized as per the type, isolation, and condition of the equipment. This causes variation of the actual work hours required to complete the task. It has been observed that the most of the seasoned technicians, more experienced, mostly support the crew and provide work instruction, but do not put in physical effort, right? Where the allocated man hours are scheduled considering the physically present workforce, including all senior and junior maintenance staff. Like the senior staff, if they will not be touching the tool, it means their man hour would be considered idle as such. Then it has been observed that the PM schedule are still being issued for the equipment that does not exist anymore due to facility change. Like it means the CMS or Maximo is not updated as per the latest asset register. Next, it has been observed that similar multidisciplinary work orders have different type and number of resources allocated. In rare cases, operation raised the work request without knowing the nature of the fault, and the work order was issued to mechanical where the fault in the system was related to electrical or controls. So conclusion point of view, if I have to make conclusion, then we will have a question answer at the end. Each organization is truly unique, and in many cases, only comparing with industry standard may not help. Considering the fact during the course of this project, a complete review of range time affecting elements was performed. It has been observed that company has very strong maintenance planning and execution procedure. Although in isolation incidents, these procedures are bypassed in attempt to basically prioritize execution based on personal judgment. If procedures are bypassed as a practice, it creates a loophole in the system that will disturb the complete planning and the scheduling process. Although it would be an extensive process, but with the recommendation made under this study should be achievable if utilized properly. And other part, if I have to make a conclusion statement before that, like, see, the first thing, when any organization is able to or willing to assess its any area of performance and whether we are performing our job effectively or there is any gap for improvement, then half of the problem is already assessed. The minute when we will be willing to see our gaps, so and then our management is open to see where are the areas of improvement, then certainly there would be areas of improvement and it will bring positive result for the organization. For this particular organization who initiated this task, so it is not the case like we got the contract, we got revenue and we were given chance to work. But see, this task orders were issued by the maintenance department itself, by the director maintenance. And he was willing to see how we can improve our maintenance activities. So when our director maintenance or senior manager maintenance division is willing to look at like where are the areas of improvement within his department or her department, then certainly it will improve the things. So the message is, whether we like or not, but we should not assume like in my engineering services or our consultancy services, as a director, if I will not be willing to look at the gaps which could be in my system, and I would be self-deceiving myself, look, everything is perfect, I am a good leader. No, I can only be a good leader if I am willing to and open to see the gaps within our system. And then we can improve ourselves if we see at those gaps and see how we can improve effectively. There are some positive things, there's always some gaps or some negative things, but we need to overcome. If we just see that, for example, here in this particular case, if you see in a year, like if we try to analyze where I initiated my discussion, like in a way, we are working 12 months, 52 weeks, 7 days a week, and still the balance is required to be maintained. But if you see that there are total days, a total 52 weeks and 5 days per week, there should be 260 days. Then the first time 10 holidays per year, let's say, but there are 30 holidays, so 250. Then if you say 15 vacation, like stock days, 235. Then if you say 15 days per year break time, 220 days. Bottom line, 220 days divided by 260, 85%. The 15 days percent man hour, the effective man days already gone, right? So now various level of range time, maximum craft time utilization is 85%, world class 70%, then very good range time is 60%, good range time is 50%, typical or to reactive is 30 to 40%, and the worst is will call out basis 10 to 20%. So here, if we see this pyramid gives us a good picture, right? This data we have taken from the data is courtesy of the Maintenance Excellence Institute. But if you see this, if we try to apply in Middle East, then like over number of leaves are 30. There are 15 national days, 8 are the minimum 8, average are the sick leaves. Then Ramadan leaves, also 1 month goes. So here to get the efficiency at up to required mark is a challenge. So same is the kind of result like we are trying to show here, like various organizations as a benchmark point wise, like bottom, third, second, and top like quartile. If we try to see here, for example, OSHA injuries are the store replacement and percentage, maintenance cost total like a sales percentage, maintenance cost replacement. So we will be basically sharing this video recording on the YouTube, and this presentation you would be able to achieve. So this is the comparison. If you wish to compare yourself, like you can compare your own organization. Like here, process metrics mean, for example, mechanic wrench time, bottom is 31%, third like a level is 31 to 41%, second level is 42 to 52%, and top quartile is above 52%, if you see it. Number two, stores turnover, which is should be less than 5% for the bottom, then there could be 5 to 7 in the third. So the second quartile and the top quartile is there. Then store issues, total material percentage, how it should be. So various numbers are available. Training and staff ratios, like a span of control, mechanics per effective planning, replacement value, and so on. So there was like a certain assumption, mean like how we created this study. So we have used certain assumptions, and everything what we did may not be perfect. It is a qualification for our team when we carried out this study practically. So conclusion point of view, if I to conclude my discussion, the wrench time, if we have to look at, we can apply in each part of the life as a student, as a working engineer, or as a like a consultancy house, or in the basically household actions, or it could be the maintenance side, inspection side as well. So the message is like if we will be looking at the wrench time effectiveness, so we will be able to see how much effective time we are spending on the actual work. And there are certain areas, if we look at them, we can minimize time wastage or ineffective work areas, and it will certainly benefit the company. So if any company is looking at wrench time study, they can do it by using their in-house resources. They can go to other consultants like Velocity, and they can carry out. But by spending by taking this extra burden, it will certainly help the organization. So it concludes my discussion. Now, Ms. Adeline and Ali, please, we ask the participant to share their questions, and then we can answer the question with our ability.
Assalamu alaikum. I am engineer Murajan from Turbat, Balochistan, Pakistan. My question is that in your discussion you said a student can use time even drinking or waiting for the tea. But how can we encourage those people or team members who encourage them to work on their free time, for example, drinking tea time or some other free time?
No. See, or my concept is on bringing that discussion. Like, if someone is reactive to the work, like I have seen example, we say, oh, I should not take tea even. Oh, I should not eat my food. Oh, there should be balance between life and work. So in that scenario, since I'm execution head and I've been working as a project manager, so my trouble have been like, if we try to give, it's not for everyone. Most of the people I would say are positive, but there are extreme situations where, for example, there is one movie, Madagascar 3. In that one, when aeroplanes crash, it's a cartoon movie, and the lion and their partners, they call the monkeys in France to repair that aeroplane. And all of a sudden, the leader was informed, all monkeys gone because they work only 2 weeks per year in France. Okay, so there have been like discussions whether, like once upon a time, there was one leave made compulsory as a part of 10 commandments in Torah, right? And now then there came 2 weeks, 2 holidays per week. Then discussion came that there should be 4 working days and then 3 holidays. There should be balance between life and work. But problem is, in this capital world, if we have to do a competitive work and competitive working environment, and all organizations are the commercially driven organizations, so how we can improve our productivity and working time? Like if you just see that in normal office, if you see around, coming in, going for tea, chatting, this. And when effective time on work comes, it comes to like a 40, 30 and that level. How we can improve it? Same example I gave, like students, like rather than effectively studying, I know I'm taking tea, no, I'm taking lunch, oh no, I have to watch also TV and so and so at the time, and 2 hours are left for the study, which is the range time for the study. For normal working environment, like in the maintenance crew, we gave examples where waiting for the work permit, waiting for the spares, waiting for travel, waiting for the other supports, for example, scaffolding and so, and then waiting for the other counter like from other disciplines. So lot of opportunities are there to where the job is not done. But if we can improve that, then our range time, our work effectiveness can be increased. And same goes to the engineering house as well. The objective of this session is how we can increase effective time for the organization on the work with the tool. Okay, sir.
Okay, sir. Thank you for your answer.
Okay, our next question is from there's no name, sir, 𝐸𝐫𝐸𝐥. I've given you permission to speak. Please unmute yourself and ask your question, sir.
You can also explain your like a background, because this discussion, because we have already presented, and normally we take 2 hours. Today we have taken only 1 hour and 15 minutes. So, and the subject is interesting one, but it's mostly for the leaders. Otherwise, the doers are sometimes try to look for balance in life and the work, but for leaders, who will do the work? That is a challenge. Question is, how can I use range time in managing manpower in packing material company? See, whatever the activity is there, so you can break down the activities in that particular process. Then you can see that where time is being like lapsed due to waiting, due to some other parties interception. So how we can improve that? So in this way, in any kind of organization, in any kind of circumstances, the concept of range time can be used, and this range time always helps to improve the productivity of the company.
He has one more question.
Okay, how frequently should range time maintenance be conducted? See, if it is done once in a 5 year, it will certainly help. There is a normal interval people follow.
So from Mr. Anonymous, his question is, what are the common issues or failures that range time maintenance aims to prevent?
See, the range time is related to increasing the effectiveness of the maintenance activities and the time on the working. Like whether technicians are waiting for spare, waiting for work permit, waiting for scaffolding, or closing job site early, so waiting for assignment of next job, and so how that efficiency can be improved, that is the purpose of range time.
This is from Mr. Hamad Shahid. I've given you permission to ask your question, sir. Please ask your question.
Okay. Sir, Assalamu alaikum. I am from Quetta, Pakistan, and I am working on a pharmaceutical manufacturing plant. The one basic, very important thing I want to ask, that we have several machines on our plant, and we do need it for preventive maintenance or corrective maintenance, but there is too much production load on the machine. So whenever the machine comes on preventive maintenance for a day or two, or for a day or a couple of days, then due to heavy production department does not give us the machine for its proper preventive maintenance. So whole year it goes without proper preventive maintenance. So in such a scenario, how can we compete on this scenario, and how can we tackle on such a scenario?
See, it is a scenario where we should pray to Allah, right? Like if the owners of the facility or the leadership of the facility is not balancing out like how much required PM or condition monitoring is required to be done, then they're taking big risk. One day this machine will break down and production would be interrupted for unspecified time. So better to plan PM activities and the due PM time or condition monitoring time should be given to technicians, and so as we can have a continuous production without any fear of failure. So this is the leadership decision. At your level, you can only pray. Sorry for this my comment, but the problem is machine has to be spare.
Okay, thank you.
Next question, sir, is from Mr. Muhammad Bilal. I have given you permission to speak. Please ask your question, sir. Mr. Muhammad Bilal.
So if Mr. Bilal is not available, I can read his question. What margin can be added in range time under extreme weather conditions? See, in Middle East, normally when temperature is more than 44 or 45 degrees Celsius, after 11 a.m. To let's say 5 p.m. or so, no PM or field activities allowed. So in this way, the activities are basically planned in the either night or the evening or the early morning. So for the weather-wise, if the people cannot work. So it has to be managed accordingly. But there are situations or the support services which can be provided to make the working environment feasible for the human being. Any other question?
We have, I think he's asking for computation, sir. Mr. Saad Mubin.
See, MTTR is the mean time to repair, right? The time which is being taken to repair that particular machine is called MTTR, 32 minutes. For that particular transmitter or particular control system, the 32 minutes were taken by the technician to repair that. Okay, if there are no further questions, we have answered all the questions. I know that this is a little sometime boring presentation, but it's a very important for the team leaders who are managing various teams, how the productivity of the team can be improved. So we conclude our session today. Thank you very much for your attendance, and we look forward to meeting you all in our next webinar. Thank you. Have a nice day.